In 2025, Amazon quietly took one of its biggest steps into deep tech, unveiling its first in-house quantum processor called Ocelot. This move marks a significant shift for a company mostly known for fast deliveries and cloud computing. But this time, Amazon isn't just building faster servers or better logistics. It's entering one of the most complex scientific arenas on Earth, quantum computing. And even though Amazon is late compared to companies like Google or Microsoft, they may be arriving at exactly the right moment. To understand why Amazon's entry matters, let's rewind slightly. The global quantum computing race has been heating up for over a decade. Google entered the field back in 2012 and made headlines in 2019 when it claimed to achieve quantum supremacy, solving a problem in 200 seconds that would take a classical supercomputer 10,000 years. Microsoft, on the other hand, has been in this space since the early 2000s, pursuing a very different approach based on topological qubits. IBM also has a strong presence, regularly publishing quantum roadmaps and giving developers access to their quantum systems through IBM Cloud. Amazon didn't really show its hand until 2019, when it launched Amazon Bracket, a service that lets developers run quantum algorithms on third-party quantum hardware like IonQ and Rigetti. But that was more of an observer role. Amazon was renting out access, not building anything of its own. That changed with the creation of the AWS Center for Quantum Computing in partnership with Caltech. And now, after years of development behind the scenes, Amazon has finally revealed its own processor, a superconducting quantum chip cooled to just 10 millikelvin, which is colder than outer space. The Ocelot chip is built around what's known as cat qubits, named after Schrödinger's cat. These qubits are designed to suppress certain kinds of quantum errors by encoding information in a way that's naturally more stable. Amazon claims that its cat qubit architecture can reduce the cost of error correction by up to 90%. That's a huge deal, because error correction is currently the biggest barrier between today's small-scale quantum systems and the large, fault-tolerant machines needed for real-world applications. Quantum bits, or qubits, are incredibly fragile. Heat, magnetic fields, cosmic rays, even vibrations from the environment can cause them to decohere and lose information. That's why quantum processors are built inside elaborate, multi-layered refrigerators with magnetic shielding and thermal isolation. At Amazon's lab, the processor sits at the bottom of a dilution refrigerator, inside a chamber that reaches temperatures 100 times colder than deep space. Surrounding that are kilometers of carefully calibrated cabling and electronics, all designed to send and receive ultra-precise signals to control individual qubits. Now, why does any of this matter to Amazon's core business? The answer lies in AWS, Amazon Web Services. AWS is a $100 billion operation and the backbone of Amazon's profitability. It's also a cloud platform, and quantum computing fits perfectly into that model. Instead of companies building their own quantum computers, which are massive and require cryogenic infrastructure, they'll likely access quantum power through the cloud. Exactly what AWS already does for classical computing. Amazon wants to offer quantum as a service, where clients can rent compute time on a quantum processor hosted in an AWS data center. This is the same model that made AWS successful in the first place, and it's one that scales. The long-term vision is clear. Quantum computing could revolutionize industries like pharmaceuticals, materials science, and cryptography. A working quantum system could simulate complex molecules for drug discovery, design novel materials with tailored properties, and solve optimization problems that are impossible for classical computers. For Amazon, these capabilities aren't just theoretical. They tie directly into logistics, cybersecurity, AI, and infrastructure, all areas where Amazon has either business interests or strategic dependencies. So, where does Amazon stand compared to the competition? In terms of time, yes, Amazon is later to enter. Google started more than a decade ago. Microsoft has been investing heavily for over 20 years. IBM has a significant hardware lead and a broad public quantum roadmap. But no one has won yet. We're still in the early stages of usable quantum computing. Today's systems only support tens or maybe hundreds of physical qubits, and they require massive redundancy to keep those qubits stable. A useful, fault-tolerant machine likely needs hundreds of thousands, if not millions of qubits, along with robust, scalable error correction. We are not there yet. estimates vary widely. Google says commercial quantum applications could arrive in 5 years. IBM is aiming for 2033. NVIDIA CEO Jensen Huang says it may take 15 to 30 years. And industry analysts like McKinsey predict the quantum market could reach $173 billion by 2040. Even modest progress in error correction could push the market to $2.5 to $5 billion by 2030. That's why Amazon's focus on error correction is so important. Their approach doesn't just throw more qubits at the problem. Instead, they're optimizing the architecture to reduce the burden of error correction itself. Their current chip, the 176P variant, has been the workhorse of their development program. And while Amazon hasn't yet announced qubit count performance benchmarks or fidelity numbers, the decision to build their own chips and fabricate in-house is a sign of deep commitment. Another advantage Amazon brings is its chip design expertise from AWS. The same engineers who design specialized chips for AWS servers are now working on quantum control systems. This tight integration between classical and quantum hardware could give Amazon a serious edge in the long run, especially as quantum systems move from lab environments into industrial deployment. But none of this will be fast. The hardware is expensive, the systems are complex, and scaling up means shrinking size, reducing cost, and maintaining or improving performance, all at once. Amazon's leadership, including CEO Andy Jassy, is reportedly aware of the challenge and involved in the quantum effort. This is a long-term play. There's no expectation of return in the next year or two. The real target is 5 to 10 years out, maybe longer. Quantum computing is still at the beginning of what will be a decades-long journey. Amazon may be late to the game, but the game hasn't really started. With the infrastructure of AWS, the deep pockets to fund long-term R&D, and a strategic approach centered around practical scaling, Amazon has a very real chance to compete, and maybe even lead, as quantum computing moves from theory to product. What they've built with Ocelot isn't yet a commercial quantum computer, but it's a solid first step, with strong technical fundamentals and a business model to match. Whether Amazon ends up dominating the field or simply being one of several key players, one thing is certain: they're no longer watching from the sidelines. They're in the race now, and they're building for the long term. Thanks for watching. If you want more deep dives into cutting-edge tech, make sure to like, subscribe, and turn on notifications. And let me know in the comments, do you think Amazon will succeed in quantum computing, or is Google still the one to beat?